Am I sharing the
Yeah, we can
screen?
see the
Yes.
slide.
Yes.
Yeah.
Good. Ah. So this is mostly slides from last year, but all of them are relevant. But I'll skip some of these just because we don't have our time is precious. We'll skip the self-introduction. We'll skip the mingle time. I feel we already mingled, so flipped classroom. It's most of these are in the syllabus. So there's a reason you're here. Mostly because you have to, but there's a reason you're in the program, right? Because this is definitely one of the, I guess, hottest area and heavily pursued skills in the job market. And funny, we're talking about machines replacing humans, right? So the better you can understand machines, there's a good than average chance that you'll not be replaced because you're ahead of it, right? So, and the next generation work professions will be those who can calibrate machines to drive up productivity. That's what companies want. Companies want fewer and fewer people whose job can be replaced by machines, but they want more and more people who know how to, calibrate machines to replace other humans. So I think you all know all of these. You can review the details from the slides. And we'll skip the mingle time. Flipped classroom. I have a lot of videos. I have a lot of resources online, and readings of the book and timeline shows you where you are and where you should be doing. Just a quick reminder, once you finish installing Python, many of you have already done, Python is working on your computer. Maybe it's been 3 months that you haven't touched it yet. Try launching the Jupyter Notebook and see if it works. If it doesn't work, then there's some loose parts that needs to be connected, but it should be a quick fix. And good. Syllabus welcome video. Hope you have watched it. And 2 books. That's PML, Python Machine Learning, DKD, Discovering Knowledge and Data. When I say, on timeline, or sometimes in slides, read this part, PML, page something something. That's what I'm talking about. This is the 3rd version. Get the book as soon as you can. I will not say that you might be able to find a digital version online, but I won't say that.
It is on a UVage library. If you search it, then you get
digital?
Yeah. I have both of them.
That's wonderful.
I can share on the team.
Yeah, that's wonderful. If you're old school, get the book. It's not expensive. It's not that expensive. It's not like $200 textbook. It's not. So sometimes it works better by having a physical book. And look at the package. You get a lot of value from it. And the other book it's classic textbook. It's not very thick, but it goes into business problems and goes into the process of understanding how the model works with the specific numbers. So that's useful. I think useful for understanding neural network process by going through the process that I don't go through. I will go through that neural network process by execute the line and explain the line of code and you know, explain to you what happens with that learning process, with that parameters. But that book pick out numbers and show you what, you know, which part changes and why. So that's, and it involves a lot of business scenarios. That's good. That's a pleasant read. And anything else that interests you about machine learning and AI? This course, what is this course about? I kind of talked about it. It's the opening up the black box for, and you know, build it from scratch. Build the model from scratch. Train from scratch. Understand the training process. I guess this is from ground up, not by using a sort of a quick line of code, but more of touching the process, and then learn how to evaluate, you know, the performance of the model. You know, how well did the learning go, and how to improve it. Through this process, you will get to questions that you would never even care about. Let's say neural network. There is a specific parameter, which is a hyperparameter, which is called learning rate. Learning rate has to be kept small, sometimes in the range of 2 to the e minus 3, which is 0.002. 2 to the 2 times 10 to the power of minus 3. That's 0.002. Why do you, can you pick a bigger number? Can you pick 1? Of course you can. Let's run the model with learning rate 1. Let's see what happens. The model blow up. Performance drops significantly. And why does that happen? So, and you know, we can look at the parameters, see what the model learned because of that off-the-chart learning rate. So now you realize that's a problem. Learning rate cannot be that large. And then you change it to something smaller. Let's look at the learning process again. You know, you find out that that's working better. You know, you'll learn how to quickly diagnose the learning process. And then finally, you see learning rate, you know, by keeping it as the first model you will learn, learning rate is 0.01, I think. Or 0.1 didn't work, so change it to something smaller. 0.01 finally works. You will start to care why you have questions like this. Why learning rate has to be small? Which part of the model is affected if you have a larger learning rate? Oppositely, if you have a too small learning rate, how does it affect the model negatively as well? So there's an optimal point where there's a range at least that works better. So, you know, those kind of questions you will understand. You will talk like an expert. If you are even in my SAS course, some of you might be also taking my predictive analytics elective course MIS. I'll also talk about neural networks, but over there it's more of a click and drag application. We would never go into only theoretically. I would talk about learning rate. The book will explain what it does. After reading, you're like, that's what it does. Let's move on. If I ask you, you know, which part of the model does it affect? I don't know. So that's the effect. That's the difference. So this is what this course is really about, opening up the black box. There are two kinds of AI, strong and weak. You might be surprised that many of the examples that you can name are weak AI. But it may feel like a bad surprise, but not really. It's just, it's just two kinds. That's it. And strong AI are those somewhat utopian kind of impression, where if an AI is highly developed and to the point that it's highly autonomous, intelligent, that's strong AI. We don't have too much of that real life examples, but I think a few examples are, if you follow the news of NASA, as well as rocket science and astrophysics, you will know that NASA has a rover on Mars. And the rover has a little buddy, a helicopter, whose name is Ingenuity. That I think that rover, as well as that helicopter, is strong AI. They're autonomous. I mean, they may run away, but can you chase them? You can't. They are running on their own program and then sending feedback to us. They are what I consider real life examples of strong AI. They are self-aware. They are aware of what they are doing. They are diagnosing their own issues, if any. Communication, that might be a communication delay. They diagnose themselves. That's one example. Then not much else. I would say AlphaGo is a strong AI because it teaches itself how to get better, and it's not hard programmed, and it's also far beyond just neural network. It's a intelligent agent, I would say, in the game of Go. So I consider it as strong AI, but there might be blurry boundary there as you go into real life examples. How do you think about Siri, Google, what's that Google agent, Google Assistant, and Alexa? What do you think about these? At this current, I think they are weak because they are confined in this space. But are they good? Are they only? So what's weak AI? Weak AI are those software agents that are simulating what humans can do well, right? Siri and Google Assistant is an extension of search engine with more, natural language processing capabilities and with real-time interactive capabilities. But are they more autonomous? I wouldn't say so. And they might be better than humans in some other areas, like they have huge memory, they have huge search speed. But I wouldn't consider, a personal opinion, I wouldn't consider them as really strong AI. But if future generations might be, I would say an intelligent agent by strict definition will be strong AI, but they are not there yet. Also with self-driving cars, this is in the news every day. So EV, electric vehicles, self-driving software. It's autonomous, yes, but ideally, if it reaches level 4, strictly level 4 autonomous self-driving software, that is considered strong AI. But I think the car will be self-aware, will make decisions and balance all the factors and make decisions on behalf of human that even surpass human in many areas, reaction, and safety concerns and vision and other things. but they are not yet, not there yet. But I consider in the future it might be. So we have a few examples of strong AI, and of course, certainly in this course, we are training, classification models to make predictions. These are weak AI, of course. These are confined. They also have limitations. They are not autonomous, but they're still AI. Any questions? So maybe a question: what will the bonus points questions be like? So I may ask you next time. I may ask you, whoever gives me the first correct answer of an example of a strong AI I mentioned in this class, the first person who gives the example correctly will get the bonus point. So that's one example. Okay. So I have Test AI Day. It's something I'm very excited to talk about, but I'll see if we have time to talk about. Whoever is into Tesla, raise your hand. Quite a few. Me too. So yeah, I'll be very excited to talk about it. But it's just it's exciting to talk about. But let's first focus on the course. I have a little comic for you. So you see doctors do that more and more. And patients complain, doctor's on the computer all the time. Doctor doesn't ask me questions. Yeah. So I think, there may be machine learning models in the back processing the images and then make some recommendations to the doctors. So that, which is fair, because once the model is properly trained, and now more and more machines are capable to make I guess predictions or diagnosis, which is far more confident than human experts, especially when it comes to images, because of the success that has been achieved in computer vision. That's just reality. Same thing. Now, so what do you expect you will do? I think I talked about these. There will be math equations, but I will walk you through to understand, for the purpose of learning these models that we'll talk about. You have a range of resources to help you and be familiar with the routine before each module and before each lecture, and try to spend more time and also think through and try to digest the materials and bring your questions to the class. That way we get more effective. You get much more effective. And we're done. For the first slide, this is mostly background course information. Any other questions? Andrews?
For overall, do we still have pass and fail, or is just grades now?
That's university policy. I can't say.
Any views on that, or?
No, not yet. At this point, we're trying to bring students back to the classroom. I think that's forget about grades. Do well, and you don't have to worry about that.
I'm still from the class notebook. Says It's an error message. It says sorry, you cannot open the page.
Cannot open a notebook?
Yeah.
Anybody else has the same issue? So, how did you, what did you click to get that message?
I clicked the frequent QA, some few questions here, like the hyperlink.
The yellow highlight?
Yeah, the highlight.
And then when you go into it, you can't get it?
It gives an error message that
Really?
sorry, can't open.
Could it be a network issue?
No.
I don't know.
I got the same message.
I was also getting the same issue, but when I used to click, they asked me to open it online, MS Teams, because I guess MS Teams has changed some policies. And when you go online and look at the class notebook, it is very different.
I tried that before. It didn't work online, but I tried it.
Yeah, I certainly hope that you're not restricted to the online web version. It should it opens up every time for me. But Teams is what I feel like a very complex software. So there are delays. There are always delays. But eventually it works. So I don't know. Let's see if we have time to let me have a closer look.
Probably works on it. Worked with the last code.
It worked fine.
Yeah, it worked fine last time.
Yeah. All right. Hopefully. Wi-Fi network today is unstable, so that might be one of the issues. Any other questions?
Have you gotten any like feedback from students who are like a little bit further along in this program, just about job offers or going out into like the workforce and kind of using what they learned here?
This course or in general?
Just in general about the program.
I certainly have names who is in their, some have graduated already,
Okay.
some are in their last semester. They either got job or they're interning. My favorite example would be this student whose name is Iman. I don't know if you know him.
Yeah. He went to go to Tesla.
Yeah, he's working with Tesla, Texas Gigafactory. I think I had a few chat with him, and
Yeah, he got a job in Tesla, but he just he's working on business analytics department, but it's just mostly because he's an intern, so
Yeah.
just mostly about like working on Excel, but it's going to be data analytics.
right. So it's certainly not what I imagined. I thought he's joining the Vision team. I'm so excited to talk to him. But it's not a disappointment. It's just eye-opening for me. I asked him, how much are you? I mean, the work that you do now. I talked to him maybe 3 weeks ago. The work that you do now, which your boss like and want you to do more. How much have what you learned at Bauer is relevant? How much is relevant? I think he said about half. Yeah, so I think that's what you would expect. You're not going to expect a job feels like taking a course and doing exactly the same. And you're not going to face a situation where nothing you learned is relevant. Especially when it comes to data. These are techniques that have specific instances, and they are made by different companies. So, I feel like this program is setting you up for a good start, at least, right? But I think the specific work responsibilities are different from what he studied in the program. For instance, one of his main responsibility is to develop a software piece inside, is that Microsoft something? Oh no, an ERP system. Develop an application or interface in that system to help the teams that he's helping. He helped with different teams to help them, help with their requests with data. His responsibility is to design these interfaces that connects their requests to the backend data. So think of it as developing a database application interface. It may sound like, commonplace or not, I guess, not fancy. But I guess the reason that he got renewed with the intern position into this fall is because in an environment where Tesla is trying to be the first in everything that they do, trying to beat everyone else. Ford, GM, trying to finish this factory and then next one and then next one to increase capacity production. What they need is speed, efficiency. With their current system, they need more. Their current system is not very good at tracking work progress of building the gigafactory, of managing the worker progresses. So that's what I come to understand. That really puts into context. I thought he's working with vision, but this is also very interesting. His work hopefully is able to save a lot of time and frustration for many other people. That's his purpose. So I guess that qualifies as one example.
Program actually helped me a lot. Yes.
Why don't you
I
share
had a
your
job. Yes,
story?
I had a job in one Fortune 200 company. And yes, everything that I've learned in database management, everything that I have learned from BZAN 6357, the class that you were teaching that, was really helpful for me. Yes, I'm using them all.
When it comes to database, it's got to be relevant. There are only this many variations, right? And there are new techniques, of course. So that course is opening eyes to new techniques that are maybe not taught in every other place that has an MIS, program. So these are very exciting. Great. So let's move on. Maybe we'll just dip our toes on a few of these slides. I'll flip through a few slides to emphasize the concepts, but reading is very important. So, Valerie?
I just want to know data strategy. So I understand whether in all these predictive modeling, what's the data strategy? What is the current answer?
Can you say that question one more time?
What is data strategy?
Data strategy. Let me think about that. Data strategy. It can be many things. It can be very broad, but I think it could come down to very specific needs of the company. specifically. For instance, I can think of a high-tech startup. A high-tech startup, if the core business model is based on collecting and I guess even selling data and intelligence, then your data strategy would be super important because that's your key value proposition. You know, Nielsen is a media company that has a lot of data about consumers, their preferences, their TV viewing behavior, audience analysis. I would say they have their own data strategy in terms of how to collect more, how to make sure they stay ahead of their competitors in terms of their assets, which is, data would be one of their core assets. So these are the things that jump into mind. This is not very relevant to this course, by the way, but I would say it's one of the key things that many companies talk about.
Okay, let's just give a bit of context because Andrew, right?
Yeah.
He asked how easy it is to get a job with what you're studying, and I want to share my experience. So I was able to get an interview with a company who wanted me to be like a data strategist. They gave me like an assignment, I collected content survey, analyze the data, build the dashboard and everything. That was good, right? So like that. And then I proceeded to the next thing. And they're asking very specific questions about data strategy. So beyond the analytics, right? Beyond all of this, how will you go about defining a data strategy for a company? And I just explained broadly, right? And they said, no, they want specific. And that was it. So in my mind, I'm thinking, what's this? I don't know what it is. Yeah.
Very good question. I think that concept is one level more abstract than the subjects that you're learning here. You're learning very specific techniques to deal with specific needs and problems of data. Dashboards would fall into this level of specificity. Data strategy would be one of the strategic management concept, which is at the same level as several other concepts. You have assurance, you have security, and I guess human resource, talent management, things like that. They are at the same corporate, strategic management level, which is somewhat beyond the scope of the degree, in fact. Or, electives will be the most helpful for you to understand that part. Right.
Thank you.
Sure. I hope. At least helpful. But I don't know even what I'm talking about. So hopefully that's useful. Anything else? All right, let's go through a few. Talk about these. In this course, machine learning is AI. AI is machine learning. The models that you learn are strictly machine learning. At least some of them are classic machine learning. Some others are deep learning, what we call, and others are natural language processing models. Three branches of machine learning, and we'll deal with two of these. You have from a classic, I guess, classic trichotomy is you have supervised learning, you have unsupervised learning, and you have reinforcement learning. We're talking about, mostly we deal with supervised and unsupervised learning because you have the algorithm, you have data. There's no multi-step dynamic game. You have data, and you try to optimize the model based on the data. I would say that's one step. Sounds like it. But with reinforcement learning, it's incremental improvement of the agent, of the robot maybe, or the software agent to do some task better. There's no, I don't think there's an optimal stage here, but here there might be an optimal solution or optimal stage. The purpose of reinforcement learning is for machines to learn to complete a task with more perfection, I guess. That's a goal. So here, but I would say these are slightly outdated. If you follow the state-of-the-art machine learning, computer science, or natural language processing scholarly field, where they publish mostly in conference proceedings, and ARVEX is one archive that published a lot of the state-of-the-art experimentations. Over there, you have this middle ground between these two, which we will not test it, but I'll just talk about it because I happen to work on this area and benefit from it. So I feel like I need to introduce to you this development so that you are not outdated. An area that's actively being developed is called semi-supervised learning, or semi-supervised. Semi-supervised learning is a combination of supervised and unsupervised, but they are in the same process. The reason for that, at least one reason for that, is because of transfer learning. So transfer learning is outside this, but transfer learning is getting more traction because the application of machine learning is being realized more and more. Its potential is being realized more and more. The need for transfer learning is where, imagine that if there is a very complex model someone developed in computer science, to really make use of it, you have to train the model with, huge data set, which also has to be high quality. Then the model becomes useful. Otherwise, your computer may not even run. Even if your computer will run that model, let's say very complex, you don't have the data. Few people have the data that is high quality. But the powerful model can be put to use by pre-training the model with data that some company has, like Google, Facebook, companies like that, Tesla as well, self-driving software. They have a lot of data. Few companies have huge high-quality data set that can train good models. And a good thing with open source is that the models are open source. They are public. They train them, they publish them for free. You can use them, although you may have to buy hardware from Google. Google has specialized GPUs that you probably have to rent or buy to run some of the powerful models. So that's one way they can capitalize on their capability, but that's another topic, right? So they train the model, they open source it, they make it available. You can use the model, you can import the model with the parameters pre-trained, and then train the model on a very similar task. Let's say, object recognition. Detect the object and detect the animal or detect the face in this picture that the model never used to train. you can train the model with very small amount of pictures, maybe 600. That's unimaginable. With 600, you can never run a model that is powerful. But with pre-trained deep neural network model, you can fine tune it. That's the term. Fine tune. Put it down. So we have pre-trained, and all of these are talking about transfer learning has two parts. You have a pre-trained powerful model, and then take that, then you provide with high quality data set, can be small, and then you go through this fine-tuning process with your limited data set, 500 pictures. Then the model, the entire model is updated bits by bits based on the supervision of the pictures that the labeled data set that you provide. The model becomes highly accurate. This is only possible if you have a pre-trained model with, that's trained by using supersized data set. And this is happening in more and more and more areas. Computer vision, definitely. And those vision models, typical models are, you have convolutional neural network, right? Or some kind of variant architecture of that. You take that, and you can even train a model on reading heartbeat, images. And then, as long as it's a supervised learning, fine-tuning process, then it can pick up signals of that, features of the, I guess, the reading, the machine. What do you call it? Heartbeat is one of the time series image data. It can recognize the features in that and, link that with the outcome. If there is a heart issue, things like that. So that's really happening in the recent 7, 8, 9 years, especially in computer vision areas. And more recently happening is in natural language processing, where the field of natural language processing as a sub area of AI, it's the text mining area. It always lags behind pictures and mostly pictures, because for some reason that's natural language processing more complex problems or a sub area. But images are, sort of a more mature, traditional area of computer science. So, but I would say recent 3 years, that transfer learning with deep learning models have caught up with vision models. Several models, I would say. BERT is one of the models, BERT. I talk about that because I use it personally in my research. This model you can search. It has different versions and different teams pre-train them and publish them. I think Google has one. And the model is pre-trained, the model I use is pre-trained with maybe several billion words of Wikipedia source, and also several billion words of another corpus. I don't remember, maybe the news article from some source. And the model itself, it has different versions. The basic version of the model has conservative estimate has 20 million parameters. Think about it, 20 million parameters. Where do they even fit in this model? BERT stands for bidirectional encoding or encoder representation from transformers. And transformer is one of the new architecture to learn information from text data. So that bidirectional means machine can learn forward and backward from the word sequence to add more context. Anyway, you don't have to know the full name of that, but the model has 20 million parameters to be conservative, maybe 200 million. The exact number doesn't matter, right? But how do you wrap your head around how is this possible? 20 million parameters. How much parameters do you have in a regular regression? 15, maybe. 15. This is 20 million. So I think after you learn about at least multi-layer perceptron, which is neural network, once you learn that, you can see how the parameters can explode very quickly if you have more complex neural network structure. And here there are more than hidden layers. There are attention layers, heads. I don't know what they are, but what happens is in one of my research, I'm trying to train a machine learning model to classify whether or not this Yelp review about hospital is complaining about the wait time. Very distinct problem. Patients complain about hospitals on Yelp and in other platforms. Yelp is one of the typical or more popular. And my task is to say, this review talks about wait time as part of the other, as part of the several subjects that this review talks about, but one of the subjects is wait time. Waited too long, or it can be little waiting time. I'm happy. Could be that, but my task is not only to recognize wait time, but also to know that this is a complaint. Confirm there are two layers, and if you think about that problem, there's an easy way. You can search keyword. You tag every review that mentions wait or time or wait time or waiting, different variations of the keyword. You can do that. And this is one of the benchmark model I compared. If you want to say accuracy of that model, maybe 84% of the time is correct. That's good, but we want better. I train neural network I have 1,000 pieces of reviews. So the size of the data set is 1,000. I have to reserve a part of that as evaluation, train test. So I train the model using 800 data points and use 200 as evaluation. And then before that, I trained a logistic regression. But after processing the text data, there's some encoding process to process it before logistic regression can do that. But logistic regression does even better than neural network. because I think data set is too few. You know, I use different complexities of neural network. I have recurrent neural network. I have long short-term memory cell. I have combinations of those. I even added in convolution neural network layers. Simpler or more complex doesn't beat logistic regression. Logistic regression is good. 89%. But I need 90 consistently. So then I read about these transfer learning. After maybe 2 weeks of struggle, my laptop doesn't even want to cooperate. Other resource, no memory. The network is so big. I have a desktop in my office that has GPU. I buy it for occasions like this. I'm happy I put it into use. So I try to make it work. It doesn't work out of resource. Why? After several attempts, finally got it work. 93% consistently. So that's how I benefit from this. You know, I'm no expert in designing neural network. I can rearrange things. I can take different layers and put them into a model. But that is half guess, half experimentation. That's it. I think those who work in the application area, that's what you're working with. But transfer deep learning is really, really powerful, hands down. State-of-the-art solution to make use of machine learning. But you have to have a pre-trained model for a task that's similar. This model can be used for a few things. It can even be used to train Q&A robots, conversation robots. If you have good labeled data set, it can be used to, find, special terms in a bunch of text if you train it well. So a bunch of things it can do. And I feel like the problem I'm dealing with is just a toy problem for the model. But we made good use of it. Turns out with GPU, with the right setup, training the model takes 3 minutes each pass. Not each pass. 3 minutes for about maybe 6 or 7 passes, epoch, which is we call it epoch, and the model quickly is trained sufficiently. Then more training leads to overfitting for sure. But so you use one of the techniques, which is early stopping, and choose the best model according to the validation data set, and then you do cross-validation to evaluate the model. 93% accuracy consistently beat all other models on every front. So that's exciting story to share. More than that, the book goes through different kinds of tasks that are under supervised and unsupervised learning. So y'all can read more about it. Megan?
I have 2 questions. I was wondering if a site for us to look at to read more about that, and also what the difference is between the semi-trained and the reinforcement.
Between semi-supervised?
Oh, semi-supervised.
Semi-supervised and reinforcement. That's very different. I think these are a group. Reinforcement is another group. What's reinforcement? AlphaGo is reinforcement. The Go game is one of the chess games of the Asian countries, Chinese, Japan. It's on a big chessboard where you have black and white. I don't know what you call it. Pieces, yeah. And you want to conquer larger areas of the chessboard. That's the objective. So Google developed this agent, I guess, intelligent agent that learns how to how to do the movement, how to play the game strategically and improve by playing with itself, by getting punished if it makes a bad move, and by being incentivized if it makes a good move. Over time, through millions of trials, the software becomes very good in playing that game. Even it beats top experts. This is back in 4 years ago. So that is reinforcement learning. It's very different from either supervised learning, where it's mostly weak AI, I would say, is make use of supervised learning. And unsupervised learning is where you don't have a labeled data set. There's no specific task, but you can still, learn patterns from the data set. We'll get there when we talk about specific models. But these two I would say they are in a group, and this is a very different group, and we don't talk about it here. That makes sense. And semi-supervised is in between. It's a combination of both. Hopefully that's clear, but it's never going to be clear if we don't do specific problems.
I heard there's an involvement learning.
There is. I don't think I heard about it, but it's possible. But
There could be a lot of learnings because it's keep on moving. So it's like how you classify things.
I'm not sure. That's one I can say. But if you have some readings, send it to me. Let me see. If it's just a name, an alias of something that we're talking about, it's good to include it. Right? It's better to know the context, what it is that about. Right? I think that's what I plan to do. And this, I feel many of you know about this, learn from another course, but you can read about this model. Basically, when we do a machine learning project, we follow the 6 phases, basically. And in business, we have more overhead. We need to understand the business problem. We need to analyze the business value before we go ahead and do it. In computing, they have very clear problem to begin with, and there's not much consequences as with business problems. So there's not many, context understanding. Their problems are much more defined. So they start with data processing and, train the model and evaluate. So that's a difference, but you have more similarities to what the later stages. It's just 2 different process models that's suitable for different fields. Like business on here, and more computing and engineering on the upper side. Different terminologies I will be using. If you have a question about a specific term, let me know. These half are more on the model side. Those are more on data, I think. These terms, I use them interchangeably. What's a record? It's typically a row of data in the table, right? And one data point is one row of data, not a column. When we say a column, we typically refer to a variable, a feature, something like that. And all of these should be relevant now, but loss and cost function, we'll get to that later when we talk about specific models. Okay, we'll stop here. The next step will be to finish installing Python, and make sure you go through completely the tutorials, make sure Python is ready, Jupyter Notebook is ready. And then after that, you can do the screening test in Blackboard. That's marked here as these, vertical boxes are I would say assignments or tests, assignments and tests. The first one in green is the screening test, so make sure you have the system set up. All right, let's call it a day.